So now let's do a problem on inverse Laplace transform. Here the question is, find the inverse Laplace transform of the signal x of s is equal to minus 5s minus 7 by x square minus 1 into s plus 1. Okay, here the ROC is defined as minus 1 less than real part of s less than 1. This is your ROC. Okay, so now let's do this question. So here I write given x of s is equal to minus 5s minus 7 by, see, if you can factorize the denominator, that is well and good. Try to factorize the numerator. Here we know what is a square minus b square, right? This is a square minus b square is a plus b into a minus b. So this s square minus 1 I can write it as s plus 1 into s minus 1 into s plus 2. Okay, so this question has three factors, right? Three factors, three distinct factors, three distinct poles. So I can now separate this into three terms. That is, I can write this as a by s plus 1 plus b by s minus 1 plus c by s plus 2. Okay, now next I'm going to find the value of a, b and c. Okay, so the equation for a is equal to, so here you can see that the denominator of a is the denominator of a is s plus 1. S plus 1 is the denominator of a. So what I'm going to do is I'm going to remove s plus 1. Remove s plus 1 and write the remaining question. So that will be minus 5s minus 7 by s minus 1 into s plus 2. Okay, see, I look at the denominator. Here the denominator is s plus 1, so I remove s plus 1 and then I write the remaining question. That is your equation for a. Okay, and then we know that s plus 1 is equal to 0, therefore s is equal to minus 1. So the value of a is this equation with s is equal to minus 1. This is the value of a. So I can write here, if I substitute minus 1 over here, it will become minus 5 into minus 1 is plus 5. 5 minus 7 by, here minus 1 into minus 1 is minus 2 and minus 1 plus 2 is 1. So this is nothing but I get minus 2 by minus 2, which is equal to 1. So therefore a is equal to 1. Next I'm going to find the value of b. Likewise b. Here b, the denominator of b is s minus 1. So remove s minus 1 from here and write the remaining question. S plus 1 into s plus 2. Okay. So now here s minus 1 is equal to 0. So s is equal to 1. So substitute the value s is equal to 1 in this equation to find the value of b. So you get here 1. So you have minus 5 into 1 is minus 5. So you will have minus 5 minus 7 by, here 1 plus 1 is 2 and 1 plus 2 is 3. So 3. You will get minus 12 by 6. Minus 12 by 6 is minus 6. Oh, minus 12 by 6 is minus 2. Sorry. Minus 2. Minus 2. Okay. Minus 2. Next is find the equation for c. C is, here the denominator of c is s plus 2. So remove s plus 2 and write the remaining question. Okay, and substitute the value. Here s plus 2 is equal to 0, so s is equal to minus 2. So substitute s is equal to minus 2 over here to find the value of c. So you will get here minus 5 into minus 2 is plus 10. So you will have 10 minus 7 by, here minus 2 plus 1 is minus 1 and here minus 2 minus 1 is minus 3. So you will get here 3 by 3, right? Minus 1 into minus 3 is 3. So you will have the answer as 1. Okay, so therefore I can say that my x of s is equal to, the value of a is 1. So 1 by s plus 1. Value of b is minus 2. So therefore minus 2 by s minus 1, and the value of c is 1. plus 1 by s plus 2. Okay. So this is the answer. Here we know the Laplace transform of this is e raised to minus t u of t. The Laplace transform of this is e raised to t u of t, and the Laplace transform of this, and inverse Laplace transform of this is e raised to minus 2t u of t, right? E raised to minus 2t u of t. Okay. So now it's time to look at your ROC and to find out if it is a right-sided signal or a left-sided signal. Okay, so here your ROC is defined, given ROC is minus 1 less than real part of s less than 1. Okay, this is the given question. This is the ROC that is given in the question. Okay, so what does this mean? What does this equation mean? This equation means that your real part of s is greater than minus 1. Your real part of s is greater than minus 1, and the real part of s is less than 1. Your real part of s is greater than minus 1 and it is less than 1. Okay, so what I'm going to do is I'm going to compare my given terms with this equation and see if it is a right-sided signal or a left-sided signal. Okay, so how do I do that? Let's take this for example. So here, according to this, here it is 1 by s plus 1, right? So 1 by s plus 1, so the pole over here is s is equal to minus 1. S is equal to minus 1 is the pole. So if you look at this ROC, what did they say about the particular ROC? The real part of s is greater than minus 1. Okay, so the pole for this is s is equal to minus 1, right? The pole for this is s is equal to minus 1. So according to your question, it is given that the real part of s is greater than minus 1. It is greater than minus 1. So this means that this term is a right-sided signal. That's how we find out. If it is greater, we say it is right-sided signal, and if it is lesser, then we say it is left-sided signal. So this is greater, so this is a right-sided signal. So since it is a right-sided signal, here there is no sign change, and your answer will be e raised to minus t with u of t. E raised to minus t u of t is the inverse Laplace transform of this. Okay. Now let's look at the second term. Here the second term, the pole is s is equal to 1, right? Because when s minus 1 is equal to 0, when s minus 1 is equal to 0, then the pole is 1. S is equal to 1 is the pole. Now what did they say regarding that pole? What was the question regarding that pole? It says that the real part of s is less than 1. It's less than 1, which means if it is less than 1, it means that the second term is a left-sided signal. The second term is a left-sided signal. So what do you do when it's a left-sided signal? We put a minus in front of it and then we write u of minus t. So the inverse Laplace transform of this is minus of minus. This becomes plus 2 into, this is e raised to plus t. This is s minus 1, e raised to plus t into u of minus t. Okay, this is how we express the left-sided signal. If it is a right-sided signal, we simply write your signal, your name of your signal, and you attach it with u of t. This is how you write a right-sided signal. Okay, and how do you write your left-sided signal? You put a minus sign in front of it, then you write the name of the signal, and then you write u of minus t. This is how you write the left-sided signal. So here minus of minus, this becomes plus, and the inverse of this is 2 into e raised to t is the inverse of this. Then you write u of minus t. Okay, plus. Now let's look at the third term. The pole is s is equal to minus 2. S is equal to minus 2 is the pole of the third term. So s is equal to minus 2, but minus 2 is less than minus 1. And look at this, it says that the real part of s is greater than minus 1. If it is greater than minus 1, then it is also greater than minus 2. If it is greater than minus 1, then it is also greater than minus 2. That means this third term is also a right-sided signal. It's a right-sided signal. So right-sided signal. So the inverse Laplace transform of this is e raised to minus 2t u of t. This is your answer. Okay. Your answer is e raised to minus t u of t plus 2 into e raised to t u of minus t plus e raised to minus 2t u of t. Okay. Here, as you can see here, the first term and the third term are the right-sided signals. The first term, because of this equation. Because of this equation, the first term and the third term are right-sided, and the second term is left-sided because of this equation. Okay, this is how we distinguish it. Now let's look at the next question. Here the next question is, find the inverse Laplace transform of this equation, and the ROC is defined as real part of s is greater than minus 1. Real part of s is greater than minus 1. So let's do this question. Okay. So here, given x of s is equal to 3s square plus 8s plus 6 by s plus 2. Here, as you can see, here it is given s square plus 2s plus 1. If you can factorize this, that is much better. We can factorize this, right? This is nothing but s plus 1 the whole square, right? S square plus 2s plus 1 is nothing but s plus 1 the whole square. Okay. So now I am going to factorize this. So this is nothing. So here, this question has two distinct poles and one multiple pole, which means this pole is repeating. Okay, so the distinct poles are s plus 2 and s plus 1 the whole square, and s plus 1 is the pole that's being repeated twice, which means you should write this 2 times. So totally there are 3 poles here, right? 3 poles. What are those 3 poles? I will say that the first pole I can start it with s plus 2 plus b by s plus 1 plus c by s plus 1 the whole square. Okay. So now I need to find the value of a, b and c. Okay. So like I said before, how many poles are here in this question? There are 3 poles. This is the first one, this is the second one, and this is the third one. Okay. Now how many distinct poles are there? If you ask me, there are 2 distinct poles. 2 distinct poles means s plus 2 is one pole and s plus 1 the whole square is also another one. You see, so I can find the value of a and c directly, because a and c has the complete poles. See, a has s plus 2 one factor, and that factor is complete over here, and also c also has a complete factor, s plus 1 the whole square. So this is also s plus 1 the whole square. So I can find the value of a and c directly. Let me find the value of a. A is, remove s plus 2 from here. If you remove s plus 2 from here, then the value of a is 3s square plus 8s plus 6 by s plus 1 the whole square. And the value of s you need to substitute is s is equal to minus 2, right? When s plus 2 is equal to 0, so s is equal to minus 2. So if I substitute that over here, I will get, here it will be 3 minus 2 square is 4, so 3 4s are 12, and here 8 into minus 2 is minus 16, so minus 16 plus 6 by, this is minus 2 plus 1 is minus 1, minus 1 the whole square is 1 itself, so it will be 12 plus 6 18, 18 minus 6 is 2, so it will be answer is 2. The value of a is 2. Okay. Now after this I can find the value of c also. Just like this I can find the value of c also, because c also has the complete factor, s plus 1 the whole square. You cannot find b like this because b is incomplete. B has one factor missing, s plus 1. You see, that factor is missing. So you cannot find b like this, but you can find a and c like this because the factors are complete. So the value of c is, remove the denominator. Here the denominator is s plus 1 the whole square. So remove s plus 1 the whole square. Then write the remaining question. 3s square plus 8s plus 6 by s plus 2. Okay. And substitute the value of s. Here s is equal to minus 1. So you will get over here is, here 3 in minus 1 the whole square is 1 itself, so it will be 3. Here it will be 8 into minus 1 minus 8 plus 6 by, here minus 1 plus 2 is 1 itself, so here it is 3 plus 6 9, 9 minus 8 is 1, so the value of C is 1. So now I found the value of C. Okay, so now I'm going to find the value of B. Alright, so how do I find the value of B? I should look at the difference between B and C. Here look, the denominator of C is s plus 1 the whole square, and the denominator of B is s plus 1 raised to 1. You see, here the power of the denominator is 1, here the power of the denominator is 2. So that means 2 minus 1 is 1. So that means I just need to differentiate the equation for C one time. Just differentiate this equation. So differentiating it, this is differentiation of u minus v. U minus v is nothing but v into du. That is, this is s plus 2 into v into du. Du, this is 6s plus 8. U into dv, v into du minus u into dv. U is 3s square plus 8s plus 6. U into dv, and dv over here is 1 by v square. This is the differentiation of this, and substitute s is equal to minus 1. S is equal to minus 1. So I get here it is minus 2 plus 1. 2 minus 1 is 1. Here it is minus 6 plus 8. So here the value is 2 minus, over here it will be 3 minus 8 plus 6. 3 plus 6 is 9. 9 minus 8 is 1. So 2 minus 1 by, this is minus 1 plus 2. Minus 1 plus 2 is 1. 1 the whole square is 1 itself. So the answer is 2 minus 1, 1. So the value of B is 1. Okay. So now therefore x of s is given by 2 by s plus 2 plus the value of b is minus 1, so minus 1 by s plus 1, and the value of c is 1 plus 1 by s plus 1 the whole square. Okay, so now we can find the inverse. Simple. So here as you can see, the real part of s, here the inverse is e raised to minus 2t, here the inverse is e raised to minus t, and here also the inverse is e raised to t into e raised to minus t, right? Okay. How to find the inverse of, you know the inverse of these two, right? We know the inverse of these two, but how do you find the inverse of this, the second factor? How do you find the inverse of this? Okay, so to find the inverse of this, that you should understand. Okay, the inverse of this is nothing but, if I am writing, for example, let me write it that this 1 by s plus 1 the whole square. If they ask these kind of question, okay, let's make it a. Let me change this question. Let it be a. So 1 by s plus a the whole square. How do I find the inverse Laplace transform of this 1 by s plus a the whole square? Okay, for that you need to understand that there is an equation called as the Laplace transform of t into x of t is equal to minus of d by ds x of s. This is called as frequency differentiation theorem, or also called as multiplication by t, because here the t is multiplied, right? So it is minus d by ds of x of s. Okay, so we know that, I know that 1 by s plus a the whole square, 1 by s plus a the whole square is nothing but the minus of differentiation of 1 by s plus a, right? 1 by s plus a. Okay, and what is 1 by s plus a? 1 by s plus a is nothing but the Laplace of e raised to minus at u of t. This is nothing but the Laplace of e raised to minus at. So what is 1 by s plus a the whole square? It is nothing but the Laplace of t into e raised to minus at u of t. Okay, just need to remember this. t into. So if you see this kind of question, immediately you can say just put a t in front of it. That's all. T into e raised to minus 80 u of t. Okay. So here the given question was x of s is equal to 2 by s plus 2 minus 1 by s plus 1 plus 1 by s plus 1 the whole square. Okay. So here the ROC is given by real part of s is greater than minus 1. Okay, greater than minus 1. So let's evaluate. Here s is equal to minus 2. Okay, minus 2. So since s is equal to minus 2, here the real part of s is greater than minus 1. If it is greater than minus 1 and minus 2 is less than minus 1. So if real part of s is greater than minus 1, it is also greater than minus 2. So this is a right-sided signal. Why? Because the real part of s is greater than minus 1 and so it is also greater than minus 2. So this is a right-sided signal. So which means you will get 2 into e raised to minus 2t u of t. Okay. Minus here s is equal to minus 1, right? S plus 1 is equal to 0. So s is equal to minus 1 and real part of s is greater than minus 1. If you say greater sign, immediately you should understand it is a right-sided signal. So this is also right-sided signal. There is no sign change and just put u of t in front of it. And the Laplace inverse of this is, you have already found it over here. It is nothing but t into e raised to minus t u of t. Here also the pole is s is equal to minus 1, which is also greater. So real part of s is greater than minus 1. So this is also a right-sided signal. So all are right-sided signals. Okay, this is your answer.